Hello there, Year 10. Back with your maths presentation for the day. I'm going to go through a starter. I'll read it through so that all of the questions are clear to you. I'd then like you to make sure you've written the questions down, have a go at the questions, halt the presentation while you're working on your solutions. Then you can switch back on and I will be going through the answers to these questions for your starter activity. So, evaluate. 4 squared, then there's a minus 14 divided by 2. The second one, 16 plus, then there's a bracket, 6 minus 8 cubed. So that bracket has been cubed. Simplify. 8a plus 5a minus 6a equals. Then we've got 8a multiplied by 2a multiplied by a equals the value of 4 cubed. Then the value of, there's a square root sign, and inside the square root sign is 8 squared plus 6 squared. So you've got to calculate that value. Then an expansion to do, expand 8x and then a bracket x plus 2y. Then you've got 2 separate brackets. First bracket is x minus 3, the second bracket is x plus 6. Solving, so getting values for x. 6x minus 12 equals 48, and then 6x plus 12 equals 8x minus 6. And then the last question on the board today, calculate a value for the angle W. The angle W is up here. You've got a triangle, and you've been given that that angle is 65 degrees. So that is your starter activity for the day. If you'd like to halt the presentation now, write down those questions, and then when you turn on the presentation, I'll go through the solutions for you. Right, okay, the solutions for you. These 2 questions, what are they about? They're about BIDMAS, order of operations, brackets, indices, division, multiplication, addition and subtraction. You must do those operations in that order. So, there's no brackets there, but there is an indices there. We've got 4 squared, so that's going to give us 16. We've then got a division. 14 divided by 2 is 7. We've now got a subtraction to do. 16 subtracting 7, take away 7, leaves us with a value of 9, and that is our solution for that particular problem. Second problem, we have got a bracket to start with. So the bracket is 6 take away 8, 6 minus 8. That gives us a value of minus 2. Now minus 2 cubed, so it's minus 2 multiplied by minus 2 multiplied by minus 2 again. That gives us a value, minus 2 times minus 2, positive 4. Positive 4 times your minus 2 takes us to a value of minus 8. So 16 minus 8, we can now do our subtraction, gives us a value of 8. Simplifying, bringing like terms together here, we've got 8a added to 5a and take away 6a. So we've got various terms all in a. Okay, so 8a plus 5a gives us 13a, and then we take away 6a, so that gives us 7a as our solution. 8a multiplied by 2a multiplied by a. Well, we can multiply the 8 and 2 together, and that gives us 16. And then we've got a times a cubed. What about 4 cubed? 4 times 4 times 4. 4 times 4 is 16. 4 lots of 16. 64 is our value. Now, we've got to deal with these squared terms inside the square root sign first. So, what's 8 squared? It is 64. What's 6 squared? It is 36. 64 added to 36 means that inside our square root sign we've got the square root of 100. What's the square root of 100? It's going to be 10. Our expansions, everything inside the bracket must be multiplied by what's outside the bracket. So 8x times x, 8x squared. 8x multiplied by 2y gives us 16xy. Two brackets multiplied together, FOIL, first terms, the x and the x squared. Outside terms, the x multiplied by the 6 plus 6x. Inside terms, minus 3 times the x minus 3x. Last terms, minus 3 times plus 6, so it's a minus times a negative, a minus times a positive, so that gives us minus 18. Bring together the like terms, x squared plus 3x minus 18 is our solution. So solving, balancing both sides of the equations. As long as we do the same thing to the left as we do to the right hand side, it doesn't change the value of the equation. We want to get x on its own. First thing we do, add 12 to both sides. Leaves us on the left hand side with 6x. On the right hand side, 48 added to 12 gives us 60. Divide both sides by 6, x equals 10. Slightly more work to do here. We've got x's on both sides, we've got numbers on both sides. We want to bring the x's together so we can ultimately get x on its own. For me, the easiest thing is to take away 6x from both sides. Take away 6x. So I have 12 equals 2x minus 6. Add 6 to both sides. Gives me 18 equals 2x. Divide both sides by 2 to get the x on its own, and x equals a value of 9. And finally, a little bit of angle work there. What type of triangle we've got? We've got an isosceles triangle. These ticks on these sides denote that these sides are of equal length. If you've got a triangle that's got two sides with equal length, it's an isosceles triangle, and two sides of equal length. It also has two angles of equal size. So 65 degrees here, this will be 65 degrees as well. Two lots of 65 gives us 130 degrees that we've used up inside our triangle. We have 180 degrees inside any triangle, 180, subtract the 130 we've used up, that gives us 50, so the value of W is 50 degrees. Okay, that's the start of going through. We now move across onto the main part of the lesson. A little bit more involved than we have been. Might have to think about this a little bit more than the last couple of days. Let's just go through some basic definitions, make sure that we're happy with them. So, first off, a line running through from one side of a circle to another through the centre point is the diameter. So that would be the diameter. Side to side, going through the centre point is the diameter. We had a line going from the centre point out to any point on the circumference. That would be a radius. Okay, from the centre point out to any point on the circumference is the radius. A line that touches, just touches the side of a circle is called a tangent. That's something we haven't done a lot of. It's just something for you to try and remember. And the term we talked about yesterday Two lines going from the centre point out to the circumference, so those are two radius. That's a radius, that's a radius. The area that is enclosed is called a sector, and that's really what we're going to be focusing on today, the idea of a sector. So we've got a radius here, and we've got a sector, which is the defined area. This curved line here, I'll be calling that an arc. It's an arc. It's not the circumference of a circle. The circumference of a circle, don't forget, is all the way around the outside of a circle. That is just part of a circumference, an arc. Okay. Just to make sure we know our formula, and you must learn these formula. There's no way around it, people. You must learn these formula. The circumference of a circle, pi d. Pi times the diameter. Another version of the circumference of a circle, 2 pi r, because the diameter is made up of 2 radius, or radii. The area of a circle, pi r squared. Don't forget, pi has a decimal value that goes on and on and on and on, but we might be asked to take an approximate value of pi, and the approximate value I'm going to be using for pi today in the calculations on the board, I'm going to just take an approximate value for pi of 3 for today, okay? Just to make the calculations easier on the board when we go through them. You will have the value for pi on your calculators and on your phones. So, yesterday we were talking about the fact that for a circle the area is pi r squared. It's simple, okay? We should know that now. For a semicircle, we consider the area of the whole circle, and then we just divide it by 2. Because it's a half circle, a semicircle. For a quadrant, a quarter circle, take the area of the whole circle, divide it by 4. Don't forget these arms here, these two straight lines are going to be the value of the radius. This line here, going all the way across what would be the whole circle, is a diameter, so it's 2 lots of the radius. Okay? Important you remember that. Let's just consider this in a slightly different way though. Consider the number of degrees you've got in here. You've got 360 degrees. So we've got a whole circle, so 360 divided by 360 gives me 1. So we keep our value of the area of the circle, pi r squared. We're not changing it. We're not giving a fraction of the circle, it's the whole circle, it's just 1. 360 degrees divided by 360 degrees, we're using all the circle. For a half circle though, what are we actually thinking about? We're actually thinking about how many degrees in our 360 have we used. We've used 180 degrees out of our 360. That equals a half. Okay, so we take our original area and we divide it by 2. Here, 90 degrees. We've used 90 degrees out of our 360 degrees. 90 goes into 360 4 times. So we've used a quarter of our area up to get the area of that quadrant. That's very important you get that idea. 360 degrees by 360 degrees, yeah, we've got a whole value, 1. Pi r squared stays the same. 180 degrees we've used up here. 180 divided by 360 degrees, half. A quarter, so 90 degrees out of our 360 degrees, so it's a quarter. What does that mean? This is a diagram of a sector. So remember I talked about this being an arc, and that's a slice taken out of a circle. So the area of the whole circle, what would the area of the whole circle be? The area of the whole circle would be pi r squared. But we've only got a fraction of that whole circle. And what's the fraction of the whole circle going to be? We've used up 60 degrees out of our 360 degrees. So that is the fraction of the circle that we've used. Okay? That would be the area of the whole circle. But we're not talking about the whole circle, we're just talking about a fraction of it. We've used 60 degrees out of our 360 degrees, so that is the fraction of the circle that we're considering, and that will give us the area of that sector. Now I said earlier on that today I'm going to keep things simple and I'm going to use a value of pi of 3. So let's put the numbers that we've got into that equation that we've formed now. So we've got 60 divided by 360 multiplied by pi, which I'm giving a value of 3 just to try and keep things simple today, and then r squared that's the radius, it's coming from the centre out to the edge of the circle, centre out to the edge of the circle, so that's 8 centimetres, and it's 8 centimetres squared, so that is all of our numbers. Now let's try and make this calculation a little bit easier for ourselves. We can cancel out a 0 and a 0, top and bottom. We can then cancel out, we've got a 6 up here. 6 goes into 6 one time, 6 goes into 36, 6 times. So we're making the calculation easy for ourselves. Now, look what we've got here. We've got a 6, and we've got a 3. 3 goes into 3 once, 3 goes into 6 twice. And we've still got more cancelling we can do. A 2 on the bottom, 2 goes into 2 once, 2 goes into 8 4 times. And what's that left us? With all that cancelling out, it's just left us with a really easy calculation here. 4 times 8 equals 32 centimetres squared for our area of that sector. Is that reasonable? We're talking about an 8 centimetre here, an 8 centimetre here. Yeah, that's a reasonable sort of answer to expect. So 32 centimetres squared for the area of that sector. I'm going to do 2 more examples before I expect you to do any examples for yourself. So here's another example. We're talking about area. The area of the whole circle, pi r squared. But we're only talking about a slice of that whole circle. We've used up 40 degrees out of our 360. So let's write all our values in again. So we've got 40 divided by 360 multiplied by pi, and again I'm going to take the value of pi of 3, keep things simple on the board, times 12 times 12. So that is our radius from the centre point to the outside of the circle. Area of the whole circle, pi r squared, but we've only used up a fraction of that, represented by 40 degrees divided by 360 degrees. Let's do some cancelling to try and make the calculation easy for our cells, a 0 and a 0. Oh look, we've got 12 here. 12 goes into 12 once, 12 goes into 36 3 times. 3 goes into 3 once, 3 goes into 3 once. So we've got nothing left on the bottom at all now, just a 1. 4 times 1 times 12 gives me 48 centimetres squared. 12 centimetres by 12 centimetres, is that roughly? Yeah, that's not a bad result to get. Yeah, I'm quite happy with that. That's in the right ballpark, right type of area for a result. Okay. Last example for today's session. I've got 120 degrees here. Area equals pi r squared for the whole circle, but we're not using the whole circle, we've just got a sector. Okay, and that is 120 degrees out of the 360 degrees that has been used. Let's put all our numbers in. 120 degrees over 360 degrees, multiplied by the value of pi. I'm taking the value of pi of 3 again, multiplied by 5, multiplied by 5. Let's do some cancelling. Right, well I know that 120 goes into 360 3 times, so that's a really easy bit of cancelling to do straight away. And then we've got 3 on the bottom, we've got a 3 on the top, they cancel out as well. That just leaves us with 5 times 5, 25 centimetres squared. Is that a reasonable answer? Yeah, okay, I'll go for that. 25 centimetres squared, it's in the right area. Okay? So that's 3 examples I've gone through of working out the areas of sectors today. In general, if you've got a sector, the angle that we've got in that sector divided by 360, multiply it by pi r squared, the area of the whole circle, and that will give us a value of the area for that sector. Now, we did, on the last lesson, have a look at these 2 catchphrases. I think the first one's really easy. I can imagine everyone got that straight away. We've got the word London, we've got the word ground. London is written underneath the ground. London underground is our well-known expression catchphrase. Yeah? Second one's a little bit more tricky. We've got the word road, which is very clear. But what have they done? They've written the word no and they've threaded it through the letters of road. And that's the key word, through. No, through, road. So that's the solutions to our last little problem. Got a new one today. First one I think you'll find pretty straightforward. So there's your first one. I'm not going to give you the answers today, that'll be in the next lesson. I think that's actually quite easy. That's probably the easiest one I've given you. Next one's a little bit more tricky though. I will give you the answers to these in the next lesson. Right. That's actually quite a tough one. It took me quite a long time to work that out. It suddenly dawned on me what it was, but it took me a long time to work it out. So that's your 2 new catchphrase tasks. There is a short SAM learning task for you to do, which your teachers can monitor for today's, related to today's presentation and your work on circles. There will be some worksheets with solutions also for you to have a go at. Use your time up. I think the last lesson was a fairly short assignment. This one, there'll be plenty of work for you to use up your hour, maybe a little bit more if you want to, but please do have a go at it. I'll give you the answers to the catchphrases in the next lesson. Good luck, be healthy.